which are the compilation, abstraction, and processes. This will be a mixture of both hands-on exercise as well as a few theory, and we'll get started with the compilation first. So, what is compilation? We, there are two sets of broad categories of compilation. So, Varun, can you just change the slides? I think I don't have to repeat that. Yeah. There are two broad categories of uh, programming languages. One is called a compiled language, and the other is called an interpreted language. So I think everyone has heard of C language, right? It's um, it's a compiled language, and most of them have heard of Python as well. It's an interpreted language. We'll get to the nuances of it as to what it actually means, but on a broad level, a compiled language means that a program that translates your source code to a machine language using a compiler. And an interpreted language is the source code is converted to um, the machine language in a way that a software interpreter actually changes it to that particular abstraction. And it is actually difficult to say distinctly that this is a compiled language and this is an interpreted language, because sometimes if you see, you can use C interpreters and Python compilers, and there are all sorts of, so for example, there are like Java Python, it's called JPython, and these are the bindings on top of each language. So you have a language, and you have a binding around the language, which can be an interpreter or a compiler. We'll get to that in future sections. Just keep in mind that there is no distinct way of saying this language is a compiled language and this is an interpreted language. But on a very high level, C is considered a compiled language and Python is considered a interpreted language. And languages like Java uses a very hybrid approach, where the programs are compiled into a intermediate language, which you might have heard of Java bytecode, which is an interpreted intermediate language, and that is again converted to the machine language using the interpreter. So the interpreter used is called Java Virtual Machine. So you might have heard of JVMs, which are often used. Next slide. Yeah. Now I'll probably just go to the terminal and show you how the type system is, and give you more examples as to how languages are again classified into static programming languages and dynamic type programming languages. So static actually means when you take a language like C, you write in such a way that this is a variable, say var or char of that particular variable name, and you assign it to something, right? Or similarly, you would do something like int and a particular variable, and that says it's an integer, and so on and so forth. And these languages are sometimes also called as safe languages, because the errors are caught in the compile time. So there are two parts when you are running a programming language. One is at the runtime, and the other is at the compile time. So what is runtime? When a program is actually running, that means to say you have compiled it and you are running it. And to show an example, probably you can. So can I share the screen? Is that possible?
Yes, Akhilesh, you can. I
Okay.
might have to stop the screen share and you can start.
Yeah, yeah, yeah. I'll just share that. Is it visible now? Upload, share an external. No. Yeah, I'll just share it. Is it visible?
Akhilesh, yes, they can see it now.
Awesome, awesome, awesome. So can you all see my terminal? Um, so yeah. So let's say, for example, when I'm writing a C code, I would write something like, include uh, CIO.h and um, and do something like, let's say, printf, right? And let's say I just right. Um, when I'm writing this, or let's say I'm saying or character C, and I assign something, right? C or something. So this particular thing where we define a variable by its type is called static typing. Similarly, when I'm writing a Python code where I'm saying the same thing, but I just write so df is for a function. So I just write add x and y, let's say, and I I just return x plus y. Uh, when I'm running this Python code, um, let's just so uh, let's say, for example, I give a value of 3 and 4. So this would return me 7, right? I'll say hello. Okay, I have not printed it. Okay, and I have to print, and let me not write it here, and rather put it here, 3 comma 4. So this would give me 7, right? But if you closely observe, we have not told uh, we have not told anything to Python saying x is an integer or a string or a float, nothing. So if you give something like a string and a integer, let's say this is a string and another, so this will give me a type error, and this happens in runtime. So when I'm running this particular file, I'm getting this error, and this is the runtime, and the compile time is where it is caught before it's actually run. It's caught by the compiler, not in the runtime. So that's the difference between C and languages like Python. So just a quick question: can you name any of the static languages you know apart from C and uh, apart from C? Can you comment it on the box? And similarly for dynamic language type of anyone? Java, right? What is Java? Is it a static language or a dynamic? C++.
Akhilesh, your audio is muted. Akhilesh, your audio is muted.
Yeah, is it better now?
Yes, Akhilesh, you can go on.
Okay, okay, sorry about that. Yeah, in compiled languages, the variable names exist at the compile time and not at the runtime, right? As we saw in those examples, and um, and it's anybody's guess, right? What languages are faster? So the static type system, there we already declare that this particular variable is of this type would reduce the time as to the language actually looking for it uh, automatically. So Python automatically assumes that this particular variable is of this type based on several factors. Uh, it might be the one which is what it's actually dealing with. So for example, if I say x is equal to 2 plus 3, so since 2 and 3 are int, it infers that x is also of type integer. But in static type languages, you have to write that integer x equal to 2 plus 3. So obviously, it reduces the time because the extra effort is by the user who is actually programming. So this is yeah, and the location of the variable is called an address. Um, so it actually points that just like how our home addresses are, similarly you have addresses for each variable. Yeah. Can you go to the next one? Awesome. Now we'll be having a hands-on session as to how the compilation process looks like, and we'll go through the so whoever has the laptop and knows how to code in C. So I would send across the code. You can just play around with it. So people who have laptop, I am sending you on the shared notes. This is the program you have to run. Yeah, it's not cut off. Can you all see in the shared notes? Include and awesome. Yeah. So copy paste in your editor and run it. Okay. now let's dissect as to how the compiler actually views. So you might have heard of compilers like GCC, right? Does can anybody um, um, can everybody um, write the full form, or have you heard of GCC? Anyone? It's GCC. Yeah. So GCC is actually a compiler for C as well as C++. It stands for GNU Code Compiler, and we'll be using that to actually see what all goes to a compiler, and what a compiler does, and the different abstractions it works through. The first thing the compiler does is it sees the source code, and the whole job of it is to convert it to the machine language, to something which the computer can understand. And it happens in different steps. And the first step is the pre-processing. So if you see on the first line, we did something like include stdio.h. So what does it mean? It means that we are taking a directive. The directive is stdio.h is a file, and we are importing that file inside our code, and that is used for IO functions, all IO operations. So first, the pre-processing is done by the compiler, and it sees that okay, this particular program requires stdio.h, which is a file, and we need to open that file and see what's there in it. And then it parses it. So from here, I'll share my screen, and you can see different ways as to how it does that. I'll just take the presenter and share. Yeah. So this is the file I was talking about, right? So this is the source code. So by source code, what we mean is something which is written by the human in a particular programming language. This is called source code. And GCC is, and let's see what GCC is. So it says, no input files are provided and compilation is terminated. How do you, in Unix, if a particular, you need to see a particular function or a particular executable as to what it's meant to do, you have something called as man pages. So it's called man and GCC. So you can see that, it's a GNU project. You can see all of the README for this particular program. So anybody who wants to, so for example, you don't have to by heart all the flags and all, right? So by flag, what we mean is something, it's usually an argument. So think of this as a function, and these as arguments. So just like how we had add function with x and y, x and y are called arguments. And these are the flags which indicate that this this particular flag contains a particular argument in certain formats. Yeah. Let's get back to how do we run this? How do you run a C program? Can anybody unmute and talk? How do you run a C program? Anybody? Or you can even type. Okay. Let's see how it's done. All right.
Akhilesh, you're muted, I guess. Akhilesh, you're muted. Akhilesh, you're muted.
Is it better now? I'm sorry,
Ye-
I don't know.
ye- Yes,
There's some
Akhilesh.
problem here. Yeah. Yeah, I was just saying, what was the last thing you heard? Um,
As soon as you took the presenter screen, they were not able to hear you.
okay. Something is wrong with the presentation. Um, just let me know whether it's able to. Um, am I audible now? Awesome. Yeah. Um, okay. Um, this is where we stopped at, right? You took the GCC compiler, and here is the source code, which is hello.c, and we are outputting that to a file called ncj, and we did that process, and we have got ncj file. And how do we run the ncj file? It's an executable, and we just do dot ncj. So it says house life, right? And this expected output, and I think we have succeeded. But this is of no fun, right? We don't know what is happening inside the compiler, and we are not able to dissect it. And GCC is so amazing that we can actually see what is going on inside the compiler by having different flags. Just like how we had /o for the output, we'll now explain how the compiler works in different stages. So the first is when we have a source code, um, the pre-processing and parsing of uh, those files happen, and it is optimized. So, for example, let's see what optimization looks like. Um, we'll we'll go here, and let's say we have something like this. Okay, so I'll explain you what dash c means. Um, we'll go to what hello hello dot o looks like. This is how it looks like, right? You can, this is how it looks like. And what does this mean? The compiler is made up of different different components, and the first thing it does is it takes the source code and converts it to an optimized form of it. So we as humans might make the code rubbish, or not so um, it's not so fast, or the way the language is written, right? Because let's say we are just learning the language and we don't know what the optimization techniques are for the language. and this is how the compiler helps us and optimizes our code. And the so this is how the file looks like, but there is a inbuilt function in Unix which is called lm, and when you do this, it says that these are the components in our code, and we'll see what it actually looks like. So it says we have a main function, right? We do have a main function. So if you look at it, um, so we have fo.c and we have a main function, right? So here is our main function, and it says so. And it says we have puts function, but we have printf, right? Why does it happen? So any idea? Not able to hear you. Okay, great. Can anybody take a guess as to why this has happened? We have in our source code printf, but in our object code it says we have puts. Any guess? Think of what we have gone through. We have, so the object code is the
I
optimized.
guess it converts the code to whichever like code the compiler has to compile, then it compiles it.
Yeah, you're correct. What we are aiming with the object code is it's an optimized version of our source code, right? So when we are having just one argument in the printf, which is just a string, it has optimized it into puts, because puts is faster than printf. So that's the reason it has done it, and it's so um, um, in a way that since there are no arguments for this printf, we have got puts. So is that clear? Like that's the reason we have got puts. And let's see from our object code what we have to convert that to an assembly code, and then that is converted to a machine language, right? So here's the process. So the source code is converted to the object code, and the object code is converted to assembly code, and assembly code is again back converted to the machine language. And let's see what assembly code looks like. And I will just, yeah. So do GCC hello C and slash f. Let's see. We have got something called hello.s, right? And let's open that. Okay. Yeah, this is how the assembly code looks like. This is a huge file with all the instructions, and this is based. So mine is an x86 architecture, the hardware architecture, and this is how the assembly code for my hardware looks like. It might be different for you, and this is how it looks like. Right. And let's see how we have got the stdio.h/t, and this is a huge file. So how do you write it to a file in Unix? So it's just through this arrow key, and let's say hello. You just write it to something like preprocess, And when we open the preprocess file, it's a huge file. So you can see this is how the file is imported to our source code. It's pretty amazing, right? It's like 731 lines. So our stdio.h is actually this big. So this is how it looks like. Yeah. To duplicate my steps, I'll put it up in the shared chat. So first, for object code, you have to run gcc and the file name, which is hello.c. For me, you can of course change it, and /3.
Akhilesh, you're muted. You're on mute. Akhilesh, you're on mute. Akhilesh, there is some problem with your earphone, I guess. That's still a faint voice from you.
Is it better? Is it better?
Yes, yes, yes. Go.
Okay. Awesome. Yeah. Any so we'll have a brief pause here and take any questions you have. So do you have any questions? Okay. Assuming it's a no. And we have two other parts, which are the abstraction and virtualization. So what does abstraction mean? It's when you see a computer, right? You can't obviously know all the things which are running now. So for example, if you're on a mobile now or in front of a laptop, so you can't seem to know everything which is happening in the background. So as a programmer, a very large part of software engineering is designing those abstractions that allows users and other programmers, so your peers or someone, to make use of this very powerful and complicated system without actually knowing all or most of it, right? Because you just have to, for example, when we wrote this file, which is hello.c, we just wanted to know how GCC compiles it into a machine language, and we didn't actually care about the RAM it consumes or the size of it, or the kinds of the important because at a given moment of time, you have to know the process it follows, where you need to know this is where I have to start, and this is where the end is, and you have to know all the steps, but you have to know it in a very abstract way, since it's sort of impossible to know all of the things which go inside a particular machine. So that's called abstraction. Virtualization is some concept which is again an abstraction where it creates sort of an illusion, right? When you are in a when you're on Facebook or let's say Instagram or whatever social media you use, it feels like you are connected to every node on the internet. So you are a particular node, and you are connected to all the nodes, and you can basically message, send videos or whatever. But the connection actually happens when you send a message or any user action you do. But it creates an illusion that we are all connected through the physical systems, but it's untrue, and we are connected through virtual connections. So only when the connection is established, it becomes a physical connection. So these are the two things that are really important to keep in mind before we go to the processes next. Now, let's see what a process is. When, as we spoke in our abstraction part, right, it is very important to keep those abstractions in mind. And process is the most integral part of it, because it isolates the running programs from that which is running on other. So in a computer, you have lot many tasks which are going on as of now, right? So processes makes it easier to isolate those tasks, and the most important part or goal of an operating system is to isolate them, because you would have a lot of side effects, right? If you run everything in uh, let's say you are opening Facebook, you are opening Instagram, or any of the social media alongside you are opening this particular course, you are on big blue button, and everything should happen simultaneously. So it might have lot of side effects, right? Because your browser is open, your terminal is open, your processes are running, your daemon processes are running behind. So that is where isolation is really important. So you have to view each task or a group of tasks as one process, and make that process non-effective to other processes, or doesn't have any side effect to other processes. So that is, and what makes it happen is a software object, and we'll go to what the software object actually has. Now, if you see, a process usually contains these information. So it has a sequence of machine language instructions. It has all sorts of information with respect to the data, which is both static and dynamic, and it takes care of the hardware state of the program and says, this is the information of the registers. These are the program counters and stuff like that. So, and it also says that if there are any pending input output operations. For example, if you're let's say you have plugged in a CD, which you don't usually nowadays, or let's say an USB, and it takes some time to open it, right? And a process waits for the data to be read from the disk or from from the USB. And similarly, it goes for networks as well. So when you go to a particular website, it takes some time to load or something, and the uh, um, and it might increase uh, um, the way the website is handled, and the status of those operations. So so you would get a better idea when we actually do it on the terminal. So whoever has the laptop, as well as people who have installed TermUX, um, we will be using that. So people who have installed TermUX, you have to do these things. So just open it, and the way we see the processes running in our computer is by typing PS. This is on Unix machines. So just do PS, and you see there's something called as ZSH and PS, which are running in this particular terminal. But this is not something which happens in my which is happening in my computer as of now. But there are more processes. So how do you see that? You go to PS dash. So try to so say that's in the complexity, right? And here you can the way you do it is I've put it on the shared notes. So say that to view the processes running just do PS dash, and you get all of it. And if you want to write it to a file, just do something like that. So and whatever begins with, and here's the interesting thing, whatever begins with K is a kernel function. So this is by the kernel. So K dot LED and K swap. These are by system D. These are the different processes. So here's a task before we end the session. Uh, People who have laptops and have installed terminals, so run this particular program and see what all processes you are running, and you have to share it. So write it to a file and keep it with you. And in the evening, we'll reconvene and we'll see what all things go into it. Just to give a recap as to what we did the past hour. So we started with the compilation. We spoke about type systems. We said these are the two ways a programming language can be categorized into, which is the compiled and the interpreted language. And we spoke about the type system, which is static typing and dynamic typing. And we saw how the compiler runs. So first, the source code is converted to the object code, which is an optimized version of the source code, and the object code is converted to the assembly code by and the assembly code is then converted to the machine language, and all of it is done inside GCC, and GCC is the GNU code compiler, and we ran the programs in C. And we saw what abstraction is, virtualization is, and the processes. So you do PS and you get all the processes which are running in your computer, and what a process object actually looks like. It has these information, um, and yeah. And here is a small part where we talk about how we can isolate the processes from each other. There are three ways of isolating the processes to eliminate those side effects we would encounter. So one is the multitasking, virtual memory, and device abstraction. So we won't go too detailed into this because when you're programming, you would definitely encounter these problems. But just to give a brief overview, so most of the operating systems have the ability to interrupt a running process, right, at any given moment of time. So if you're running any program, you can just do Control C and you can just terminate it, or you can just pause few processes and resume it again. And similarly, you have something called as virtual memory, which again creates an illusion that each process has its own chunk of memory, but in reality, it's not the case. When you start programming, you will actually get to know why this is important. And device abstraction is the processes running on the same computer share the disk drive, the network interface, and other hardware, but it's all in an abstract way, right? The hardware is used through a particular abstraction, and this is how we can isolate different processes. And yeah, I think we are done with the session. The second part of the OS introduction will be in the evening. Till then, uh, try to go through the different processes we have, and I think that's about it. Yeah, on command prompt you can write task list to actually see different processes which are. Yeah, I think we are done. If you have any questions, please feel free to unmute or type it on the chat. I think that's no questions. So please feel.
Akhilesh, you're on mute. Akhilesh, you're on mute. Um, Yes, Akhilesh. So if anyone has any doubts or queries, please stay back for a few minutes. We can clarify your doubts, and we'll have another session where you will, if you haven't understood any of these concepts, it will be clarified in that session as well. Like we will show how the architecture of the OS is actually architecture of Linux OS or the Windows OS or the in general the OS itself. So those are the topics that we'll be covering in the evening section. So I think we are done with the session. So if anyone has any doubts, you can just put it up on the chat, or just you can unmute your audio and then talk. We'll stay here for a few more minutes. Pramod, I think that is from your college lecturers. I think you have to fill in it as it's a kind of registration, sorry, for the attendance purposes.
Which compiler do we need in Windows? GCC is available in Windows, right?
Pramod, GCC is the compiler that is from the GNU that works only on Linux. I think there might be some other
Yeah,
alternative.
I just found some version for TDM GCC. It's fine if I use that, right?
Yeah, I
For
think
Windows.
if it is for Windows, I think we have to look into it and then we can get back to you.
Okay.
Is there any other questions? Please feel free to ask. Okay. If not, we can wrap up the session. So here's the link for the presentation that we have, Akhilesh has shared in the chat section. And we'll also be sharing the recorded session. If anyone have missed that, we'll be sharing it across the mail and then also on the Zulip chat and also on Discourse. So that's it, I guess. Yeah, don't skip the evening session. It is much more important, and you will get to know everything. Like everything will fall into place. So whatever you have heard right now, the topics, you will understand it better. I think, Akhilesh, we should end the session, right? Okay, then. See you all in the evening at 5. Have a good afternoon. So everyone can leave the session. Just end the session, log out and end the session.